So today we're going to continue our conversation of the mole, and we're going to talk about the difference between what is a molecular formula and what's an empirical formula. So you can see the vocabulary on your screen, and I would like you to know the difference between a molecular formula and an empirical formula, and to be able to take the molecular formula and go to the empirical formula, and then we're going to learn how to go from the empirical formula to the molecular formula as well. So the molecular formula is the actual formula of the compound. For example, some of you may know what C6H12O6. That's the actual formula for glucose, glucose being your blood sugar. And so it has 6 carbons, 12 hydrogens, and 6 oxygens. So that makes up a molecule of glucose. That is a covalent compound there. And so, but this could be simplified. We could take this formula and we could divide by 6, and what we're going to get is a ratio. We're going to get the simplest ratio, which is known as the empirical formula. So I would get C1H2O1, again, ones we don't write. And so this is the simplified version of that. There are a lot of compounds that have this empirical formula, but glucose has that molecular formula. So molecular, the larger actual formula, the simplified is the empirical. So if we had C3H9O6, can you see that we could reduce this all by 3 this time, and you get C1H3O2. So smallest number that will go into each. So there are some on your test where you're just simply going to, I give you the molecular, you're going to reduce it down to the empirical. Not bad at all. There are times where the empirical and molecular are the same formula, so that does happen as well. So for example, like water, that is the actual formula water, and it is also the empirical formula for water, or dihydrogen monoxide. So we're going to look at some steps on how to do this, and I'm going to on each video do one example. And so these are the steps. It is on the PowerPoint, and so if you want to just pull up the PowerPoint and as we go you can see, but completely up to you. But these are what we're going to be doing. So I'm going to go on past that. If you need to come back to this, again, it is on the PowerPoint. You can pause this video. But I think after we do a few, you'll kind of catch on. All right, so our first one, it says we have a compound that's made up of carbon. So we know it's got some carbon, and we know it's got some hydrogen, and it says some oxygen. So we know that it's carbon, hydrogen, oxygen. I just don't know how much of each that it has. I know that it has carbon, hydrogen, and oxygen, and it is a compound, so they're not individual elements, and that's important for us to know that it's not hydrogen by itself or oxygen by itself or carbon by himself, so they're not diatomic in any way. So I know that 40% of it is carbon and 6.71% of it is hydrogen, and some other part of it is oxygen. And I could figure out how much of it is oxygen because I can add my percentages together and subtract them from 100. For example, 40 and 6.71, I know that the carbon and hydrogen are 46.71% of that. So how much is oxygen? Well, I can go 100 minus 46.71, and I can figure out that it is 53.29% of this is oxygen. Okay, so not hard. Percentages do add up to 100. So what we're going to do is we're going to figure out this percentages, but we're going to take it to the mole. Now, we haven't learned how to go from percentages to mole. We've learned how to go from grams to mole. But if I said we had a 100 gram sample, and anytime you have percentages, you can say, well, if we had a 100-gram sample, because we're just looking at ratios, how many grams of it would be carbon? Well, 40 grams of it would be carbon. How many grams of it would be hydrogen? Well, 6.71 grams of it would be hydrogen. How many grams of oxygen? 53.29 grams of it would be oxygen. So if you see percents, you could just treat them out of a 100-gram sample. So I'm going to take 40 grams of carbon, and I'm going to convert it to the mole. And by now, we should be able to know that grams of carbon would go down. 1 mole of carbon would go on top. We're not using Avogadro's constant because it's grams, so we use some molar mass off the periodic table, and that would be 12.01. So when we do this is not going to be our end answer. So I'm going to have you go out what I say several decimal places. And what I would consider several decimal places, what I would like you to go out at least 4 decimal places. Because if you try to round too much, you're going to get bad answers here. So you're going to get 3.3306. And that's how many moles of carbon are in my sample here. And now I'm going to do the same thing with hydrogen, 6.71 grams of hydrogen. It's not going to be diatomic because it's part of a compound. And we will talk about diatomics very soon. So it's just H when we do an empirical formula. This is 1.01. And when I divide that out, I get 6.6436, taking it out 4 decimals if it's not coming out to be a whole number. And then we've got one more here. See if I can get that to scoot some. We're going to do the 53.29 grams of oxygen. Grams of oxygen to moles of oxygen. That is 16.0 if you want. We'll divide those out and we get 3.3306 moles of oxygen. So once they're in the mole, you're going to look and you're just going to say, okay, well, out of these 3 numbers, which one's the smallest? Well, 2 of them are the same, so that's going to make our life a little easier. And you're going to divide, and I'm going to switch colors just so we can see. I'll switch by black. We're going to divide by the smallest. So I'm going to divide all these numbers by the smallest number. And that comes out to be 1. When I divide this one out, it may not come out evenly to 2, but it comes out, and I don't have my calculator near me, but it comes out really close to 2. It's either 2.0 or 1.9. So really close. When I say really close, it has to have a 0.0 ending or a 0.9 ending. That's important. 0.0 ending or and then we're going to do it as a whole number if it comes out to those 2 endings. So this one we're going to say is 2. And then, of course, this divided by itself would come out to be 1. So what that gives me is the question marks here. And you're going to put them right back in the same order. We have carbon is 1, hydrogen is 2, and oxygen is 1. Again, ones you don't have to write, so you could just write it as that. All right. So if we had already been given the moles, we would just divide by the smallest moles. There's some on the homework where you've already been given moles, and you'll just divide by the smallest mole. And so if they come out to be whole numbers, then they just become the subscripts, and that becomes our empirical formula. Okay, just like that. All right, that's all for this one. We're going to do a harder one on example 2. So our next video, please watch.